Section 11.3, areas of circles and sectors. We know the area of a circle is going to be equal to pi times our radius squared. If we're going to find the area of a circle with a radius of 7, we just plug that in for r. Our area is going to equal pi times 7 squared, which is 49 pi, or approximately 153.938 square units. If we're going to find the diameter of a circle with the area of 84, we plug in 84 for our area. So we know 84 is going to equal pi times r squared. We solve that for the radius and multiply it by 2. So our radius is going to be equal to the square root of 84 divided by pi. We double that, that's 2 times the square root of 84 all over pi, which is approximately 10.34. Here we are asked to find the radius of a circle with an area of 45 square inches. So we know area equals pi times our radius squared. If our area is 45, we know 45 is going to equal pi r squared. We can divide both by pi. So 45 over pi is going to equal our radius squared, but we don't want the radius squared. We want the radius. To get rid of that square, we square root both sides. So our radius is going to be equal to the square root of 45 divided by pi, which is going to be approximately 3.8 inches. Area of a sector is going to be equal to the measure of our arc divided by 360 times pi r squared. We should notice a correlation between this and the arc length formula. Arc length is the same thing except we're multiplying by 2 pi r because 2 pi r is the circumference. With arc length, we want to find the fraction of the circumference. So we use the circumference and multiply it by the fraction of the circle, which is whatever our angle over 360 is. Here we're looking for the fraction of the area because our sector is be similar to a piece of pizza. It's that area from that includes the arc, and the two sides are the radius. So here, if we're given a sector with a radius of 4 and an arc measure of 70 degrees, we can find out how big that sector is. It's going to be equal to 70 over 360 times pi times 4 squared, which is going to be approximately 9.773. A and B are on a circle P. The radius of the circle is 8, and the measure of angle APB is 35 degrees. Find the area of the two sectors formed by angle APB. If we start with the smaller sector, we know that the angle there is going to be equal to our arc measure, which is going to be 35 degrees. So we're going to have 35 over 360 times our pi r squared, or times pi times 8 squared, which is going to be approximately 19.54. On the other hand, then, we know that the bigger sector there is going to be using the other arc, which would be 360 minus 35, which is going to end up being 325 all over 360, again, times our pi times our radius, which is 8 squared, which is going to be approximately 181.54. In this problem, a pizza has a diameter of 14 inches and is cut into 8 congruent slices. What is the area of one slice to the nearest hundredth? So we draw our pizza. We know it is a circle. It's got a diameter of 14, which means the radius is going to be 7. If each one of those slices is equal, they're going to have an equal angle, which means we have an equal measure of, or an equal sector measure for each one of their sector area. So we plug that into our formula. We know the measure of each one of those angles is going to be 360 divided by 80 because of each one being equal. So that's going to be each arc measure then, or each angle measure, is going to be 45 degrees to make those into 8 equal slices. So we put our 45 over 360. We multiply that by pi r squared. In our case, our radius is 7, so pi times 7 squared. We plug that again into our calculator. 45 divided by 360 is going to be 1/8. 1/8 times 7 squared would be 49, so we've got 49 over 8 times pi, and that's going to give us the area of each one of those sectors, which is approximately 19.24 inches squared. Here, the area of a composite figure by adding. If we look, there are three unique shapes here. We've got two semicircles, which combined would make a full circle. We've got a rectangle and we've got a triangle. So we just need to add up each one of those areas. We know the area of the rectangle is going to be base times height. We know the area of the triangle is going to be 1/2 base times height. And we know the area of that semicircle is going to be 2 times each half of that. So 2 times 1/2 times pi r squared, or really just pi times our radius squared. We know the base and the height of that rectangle. The base is going to be 32. The height is 16. The base of our triangle is going to be at 32 again. The height is going to be 15. And then our radius of the semicircles is going to be 8 because our diameter given to us is 16. Half of that would be 8. We plug all of that in. We add them together. Our 512 plus 240 plus 64 pi. We're going to get an answer of approximately 953.1 square feet. Here we asked to find the area of the figure in square feet round to the nearest tenth if necessary. So we have two triangles here and here. We've got a rectangle and we've got a semicircle. We know the area of the two triangles. Since we have two of them, we're going to multiply by 2. Is going to be equal to 1/2 base times height. Our base is going to be the 5 feet, so times 5, times our height, which we can see is 8 feet. So we multiply that together. 2 times 1/2 is just going to be 1. 5 times 8 is going to be 40. So the area of the triangles is 40. That equals the area of our triangles. The area of our rectangle is just going to be base times height. So area of our rectangle is going to equal 18 times 8. That's going to equal 144. And then we have the area of the semicircle, which is going to equal 1/2 pi r squared. So 1/2 pi times 9 squared, which is going to end up equaling 81/2 times pi. We add all of those together, and we're going to get approximately 311.2 square feet. Here we're asked to find the area of the shaded figure. We know that's going to equal the whole rectangle, the big rectangle, minus the area of the smaller rectangle. That white part that's unshaded, we're going to subtract away from it. So we know we're just going to have base times height minus base times height. We know the base of the big triangle, or big rectangle, excuse me, is going to be 150. We've got the 100 plus the 25 on each side of the little rectangle is going to add up to be 150. To find the height, we've got 25 again on either side of the little rectangle, and the height of the little rectangle is 20. So the big one is height is going to be 70. We're going to subtract off the little rectangle, which is 100 times 20. So we're going to get 10,500 minus 2,000 for a total of 8,500 square feet. Here, Kara wants to design wallpaper, or she wants to wallpaper one wall of her family room. She has a fireplace in the center of the wall. We need to find the area of the fireplace. So again, that is going to be the big rectangle minus the little rectangle. Big rectangle, we're told, has a base of 18, so we take 18 times the height, which is 10. We're going to subtract off the little rectangle, which makes up our fireplace, which is 6 feet times 4 feet. So we've got 6 times 4. So we've got 180 minus 24, which is going to equal the area of that wall around the fireplace, which is going to end up being 156 feet squared. Again, we're asked to find the area of the shaded region. Here we notice that the shaded region is a rectangle with 2 circles taken out of it. So we need to find the area of that rectangle. And if we notice that area of the rectangle is going to be equal to 4 of these, or the area, the base of this is going to be 4 radii long, which is going to end up being 36. The height is going to be 2 radii long, which we're showing there. So that's going to be 18. So we take our length times our width. We're going to subtract off the area of those two circles. So we're going to have 36 times 18. We're going to subtract off 2 times our pi r squared, which would be pi times 9 squared. We're going to get 648 minus 162 pi, which is approximately 139.062 units squared. Again, we have a blog due for tomorrow. We will be working on our homework checks in class / on your own. Have a wonderful